So packet from yesterday if you want the clean version, page 26. All right, so yesterday we talked about two of the congruency postulates. We talked about side angle side and side side side. There are a couple more. There is angle side angle, angle angle side, and hypotenuse leg. Those three we're going to talk about today. All right. So overall, those are all the postulates that you can use to show that two triangles are congruent. All right. No other combination works to show it's congruent. It doesn't give you enough information. All right. So SSA, ASS, AAA, none of those work. All right. So first off, we're going to start with ASA. So that just means angle side angle. So it's similar to side angle side, but instead of two sides with an angle in between, you got two angles with a side in between. So this is angle, side, angle. And again, that just means two angles in the included side of one triangle are congruent to two angles and the congruent side of the second triangle, then the triangles are congruent. So, for example, this first one, they're saying GHJ is congruent to FEG, and it's congruent by angle side angle, because if you look, we have an angle that's congruent, another angle that's congruent, and then the side that's congruent is directly in between of them. So you got two angles that are congruent, and then the side, that tick, is directly in between those two angle ticks. So again, in order to figure out what postulate you're using, the way I like to do it is think of it like a circle. Just pick a spot and roll with it. All right. So I'm gonna pick the furthest thing where there's nothing else on either side of it. I'm going to actually die. Okay. This is like the fourth time today that it's done this. I may be loved, but I'm about to cuss. So that projector is about to get a baseball bat taken to it, I swear. If you could just let me borrow the baseball bat back. All right, so start where there's nothing else congruent on either side. So like, for example, this yellow angle right here, there's nothing else congruent on one side of it. So I'm gonna start there. That's how I know what I have to start with. So I start with an angle. The next tick that I see that's directly next to it is a side. And then the next tick directly next to that is an angle. So angle, side, angle. All right. So what about this one? Would this be angle, side, angle? Yeah, why? HJ is congruent to itself from the reflexive property. So we can mark that as congruent because of the reflexive property. Thus, we have an angle, a side, and then an angle. Now, the reason that I'm saying use that circle method is because look at what the next theorem is. Angle, angle, side. The same combination, pretty much, but they're in different orders. Okay? And yes, the order does matter. So, angle, side, angle, side are two angles and a non-included side, meaning it's not in between the two angles, where of one triangle is congruent to two angles and the corresponding non-included angle of the second triangle, then the two triangles are congruent. So, like I said, kind of pick something that doesn't have anything congruent on either side of it, or pick the one that it kind of looks like it's out of place a little bit. So for this one, this would be angle, angle, side because we have a congruent angle, another congruent angle, and if you look, the side is only next to one of the angles. All right, so the side should only be connected to one of the angles, not both. Previously, it was connected to both. But for this one, it's only connected to one of the angles. In that case, it's the green one. So the way we would read this one is angle, angle, side. You could also do it like this, angle, angle, side. All right. So the difference between angle, side, angle, and angle, angle, side. Angle, side, angle. The congruent side will be the side that makes up both angles that they share. All right. For angle, angle, side, it's the side. It's a side that's only being made up of one angle, or that makes up one of the angles, not both. Does that make sense? What about this next problem? Is it angle, angle, side? Yeah. Why? Right. Reflects the property states that side's also congruent. So we now have two angles and a side, and that side is not between the two congruent angles. So angle, angle, side. Any questions so far? Now, remember what I said about the third angles theorem. So it states that if two angles of one triangle are congruent to two angles of a second triangle, then the third angle or third angles of the triangles are also congruent, because obviously by triangle sum theorem, if you have two of the same angles between two triangles, so say you had a 100 and a 50 degree angle in both triangles, obviously the last angle has to be 30. All right. As long as it's like, they don't have to be bigger than the other. Like, it could have been like, both angles were 50. That means that the third one has to be 80.
Okay, but like they'd be the same scale, just like one of them would be like.
So this gets into kind of our next thing. Can three angles prove congruency? All right. So what do you guys think? Can you have, knowing that three angles are congruent and no sides are congruent, prove congruency?
Yes. Actually,
No, you can't. Because if we know that three pairs of angles are congruent, well, those angles are congruent, but they're not the same size. So that's kind of where dilation comes into play, guys. So with dilation, the angles remain consistent, but the sides change. So the side lengths do not. Remember, for triangles to be completely congruent, every aspect of them must be congruent. So that means sides and angles. Does that kind of answer your question, Riley?
yeah.
Okay. All right. So now, angle does prove similarity, which we'll talk about in the next unit. But it does not prove congruency. So again, just to sum this up, let's say that this angle was 50. That means the other one with one tick is 50. This angle was 100. That means the other one with two ticks is 100. So what must the third angle be? 30. So that's what the third angle theorem states. If you have two sets of two congruent angles between two triangles, obviously the third set has to be congruent. So now, using what we know so far, and that includes the stuff from yesterday as well, let's see if we can prove that these triangles are congruent and by what theorem. So, number one, first off, can I mark anything else on the picture in number one?
Yes.
Yes, what? the side that they share. So once I do that, are these two triangles congruent? Yes or no? Yes. By what postulate? ASA, angle side angle. Because you have an angle and an angle with a side in between them. Or if you want to think about it, or if you want to think about it this way, this angle includes the congruent side, and the other angle includes the congruent side. All right, so both angles should be made up of that side. That should be one of the rays of the angle. What about 2? Right, the line in the middle is congruent, and yes, we can say it is by ASA. Because remember, 90-degree angles are congruent to themselves because, duh. Yes, ma'am.
If you write like what it is like the ASA, do you also need to write what's the property, or is that just how you get it?
That's how I know. So these are the abbreviations. If you just write the letters, I know what that is. Desmos knows what that is. Like that's kind of like a mathematical standard. Like we typically use the 3 letters. You don't have to physically write out all 3 words. Yes. Okay.
Exactly. I can understand like the first line, what was the second and third one? Like for like 4, for example.
Yeah. So when it comes to tick markings, when it comes to the tick marks, like I said earlier, it's just a matching game. All right. So typically, mathematicians we want things to be as simple as possible so we can save our brain power for the hard calculation. All right, or the hard logical reasoning. So when it comes to notation, we make it fairly obvious. All right. So remember what I said. When it comes to these tick marks, it's a matching game. Okay. So in other words, this side that has 3 ticks will be congruent to the side that also has 3 ticks. All right. And it doesn't really matter how many ticks you put. I could have put 2 ticks here, and it wouldn't have mattered. All right. As long as you put the same number of ticks, it doesn't matter. You can put 100 ticks if you want to, but so does that kind of answer it a little bit more? So it's just a matching game. That's all it is. Now, depending on what the tick looks like can mean different things. So for example, a straight line tick on a side means congruent. A little angle symbol right here, that means congruent. Whereas an arrow means parallel. All right. So that's kind of where you got to know what the ticks actually mean. But besides that, it's a matching game. Does that kind of make a bit more sense? All right. So what about number 3? What do you think? Can I mark anything first off? Yes. What can I mark? The vertical angles. Now, these angles, I'm going to use 2 little semicircle type looking things to mark those angles because we already have 1 pair of angles marked with 1. All right, we want to make sure that we know that this angle is congruent to this angle, but it's not congruent to these angles. All right, at least we don't know if they're congruent to that angle. So does that kind of make more sense with the ticks? Why I do what I do with the ticks? Yes.
Why would you place it in the middle and not like on the outside corner?
I mean, it doesn't really matter. Like, I mainly, like, for angles, it's more so, like, if you actually, like, let's say we forget the triangle for a second. Let's just say we drew an angle. Typically, the angle is the distance from one point on a ray to another point. All right, and it's like you're going around in a circle. That's where angles come from. Angles come from circles. And saying that if you pick a point on a circle and you travel along it to another point, how big is that arc? Which you guys will learn all about in Math 3. All right, but That's why they use this symbol, because it signifies the actual distance that's going on with the angle. All right. So angle symbols are typically used like this. Now, some mathematician long time ago was like, oh, well, instead of just showing that that's an angle, we can also use it in terms of congruency. So, if you have another angle next to this one and they have the same number of ticks drawn, then they are congruent. So, like if I drew a second one here, but not here, that means these two angles are different measures. So that's why I say it's a matching game.
Yeah, so pretty much the one, say like the one at the top corner on the 3, that would be congruent to the one at the bottom of.
Yes.
Yeah.
Yeah. So if like we did show that, then they would have possibly 3 ticks.
Yeah, but like why would you mark?
Why we would mark it? Because remember what I said. We need proof to show that those angles are congruent. We haven't even stated that the triangles are congruent yet. Which, as soon as we state the triangles are congruent, then yeah, we can go ahead and mark it. Because remember, CP, congruent corresponding parts of congruent triangles are congruent. But, however, if this was like a legal case, all right, we had enough evidence to prove that these two angles were congruent because they're vertical. We always know that vertical angles are congruent. But there's no clear connection between these two angles because we don't have enough information to show they are. All right. So remember what I said. We have to have proof. We can't just assume. So here, now if they freely give it to us, that's viable information. If they already marked these two pieces, then yeah, that is God's word. It's true. That's what it is. But otherwise, we cannot just assume. The only reason I mark these is because I know for an absolute darn fact those are vertical angles and vertical angles are congruent. Does that make sense? So speaking of, would these triangles be congruent? They are. By what postulate? Angle, angle, side. Now, what about number 4? So do I have anywhere that I could legally mark congruent? Anything else that I could legally mark congruent? No, I do not. There's not enough information to mark anything else congruent. So we have to do it based off of what is currently marked. So can I completely, without a freaking doubt, say that those two triangles are congruent? Nope. I don't have enough info. Yes, ma'am.
So how do you know which order to put like letters in? Like I know you said like a circle, but like would you go?
Well, think about it this way. If like say you start with the side first. If you say side, angle, angle, well that's technically not a postulate, but if you flip it backwards, it's angle, angle, side. So if you know what all the 5 postulates are, even if you circle it around, all right, and if it doesn't look like one of the postulates, but it looks like the postulate backwards, then that's what it is. And to be honest, the only one that doesn't work is SSA. Unless you're about to see the only exception to that. All right, so pretty much you just got to be careful. So for number 4, we definitely do not have enough info. So like I said, you got to take everything at base value. All right. If there's not enough information, there's not enough information. Look at number 7. So based off of what's marked currently, could I say that these two triangles are congruent without a doubt?
Yes.
We don't have enough information to show these are congruent because only the angles are marked. Remember what I said. Now, to the naked eye, these do look congruent. But remember what I said, you can't take anything at face value. For all we know, this is bigger by a scale factor of 0.1. All right? They're off by a decimal place. That does not make them congruent then. There's not enough information to show that. So if all 3 angles are marked as congruent, not enough information to show it's congruent unless we have at least one side that showed it's congruent. All right, does that make sense? Because again, even to the naked eye, if we took a ruler to this, who knows? Maybe they might be congruent. But at what we see currently, there's not enough evidence to prove these two triangles guilty. Yes?
So if the sides, all the sides are congruent, but the angles are, would that still be congruent?
Yes, because that's side, side, side. So the biggest thing with congruency is the size. All right, so remember, same size, same shape. The shape comes from the angles. All right, but shape doesn't necessarily mean the same size. It could be the exact same shape, but not the same size. For example, you could have two squares sitting right next to each other, but one's bigger than the other. It's the side lengths that dictate the size. So typically, when it comes to congruency, you're going to have at least one side congruent. All right. So this one, not enough info. All right. So they're asking, what additional piece of information do I need to prove to make sure that these triangles are congruent by ASA? So based off of this triangle, I wanted to prove it by ASA, so angle side angle. What piece do I need to show is congruent? Now, we're not going to actually show that they're congruent, but what piece would make it congruent? What do I need to add on to it? You can either add on one of the angles D, or you could add on angle B. Either one of those. So you can either show that angle ABD is congruent to angle CBD, or you can show that angle ADB is congruent to angle CDB. Either one of those would show that they're congruent. Well, no, I lied. It's only angle B. I lied. My bad. It's only angle B. Because if I mark angle D, are those, is that congruent side in between the two angles? No. So that would not be by angle side angle, it would be by angle side. They want angle side angle. So it would have to be these two angles. Yes, ma'am.
Okay, so is that just how you would prove that?
So proofs, which we will get into later. If you looked at your Delta math yesterday, you know those flow chart things that you saw?
Yeah.
Those are proofs. All right, those are technically proofs. They're distinctively easy ones. All right. So I'll tell you what. After I get through this lesson, I'll show you what a proof looks like. Like, yes. What's the other questions?
Oh, it was just about the stuff we did before.
Okay.
I can ask you later.
Okay. Well, I'll show you guys a proof. Like, I'll go through a proof with you guys after we do this stuff. Like, I'm not going to make you guys do it, but I'll show you what it would look like. Because I feel like you guys are getting it, but you're still kind of curious about what it actually means to prove it. Okay. What about this one? What do I need to show? Which angle do I need to show that's congruent in order for it to be angle side? Right. You need to show that JKN is congruent to MKL. So then you have angle, side. So we need to show that NKJ is congruent to MKL. So guys, this is one of those examples of why you can't just name it a simple letter, because if we just named it angle K, which angle are you talking about? This one or this one? All right. That's why you got to use 3 letters. Okay. Because sometimes, remember, some angles do share a vertex. So if you just name it based off of the vertex, well, which one are you talking about? All right. Now, the last thing we need to talk about is hypotenuse leg. Hypotenuse leg is the only ass that works. All right. So, triangle congruence postulates that do not work. So, you need to write these down. Any iteration of angle, angle, or angle, angle, angle. Because we could say it is angle, angle because of the third angle theorem. Or you can just say all three angles are congruent. Because while it does conclude, I won't make that bigger. While it does give same size, sorry, I said the backwards. While it does give us same shape, it does not necessarily give us same size. So, angle, angle does not work in terms of congruency. The other one that doesn't work is side, side angle, which be that as it may, what it's spelled backwards. All right. So, and the reason is because since that angle is not connected to both sides in some shape or form, we can still draw a different line. So, like, say these sides were congruent and then this angle is congruent. Remember what I said. A lot of times you can have one congruent angle in triangles, but depending on the length of these sides, even if these sides are congruent, even though this angle is congruent, since this angle is not connected to both of these sides at the same time, then the distance here could be anything, as long as it makes that triangle connect. All right? It's because this angle is not connected to both sides. Because did you notice that the only theorem with two sides in it was side angle side? The reason for that is that as long as these two sides are congruent and they're at the same angle, that dictates how long this third side has to be. All right. And then of course, side, 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 of course, that'll be congruent because it's the same size. And as long as it's the same size, it's going to be the same shape. Now, here's the only special case of SSA, and that is HL, which stands for hypotenuse leg. So, the only way that SSA works to prove congruency is if you have a right triangle. So remember, a hypotenuse exclusively comes from a right triangle. So it only works if you have a right triangle. And both of them are right triangles. So for example, let's say that I had a right triangle and I had another right triangle. If the hypotenuse or hypotenae are congruent, I think the plural of hypotenuse is hypotenae. If the hypotenae of the two triangles are congruent, and one of the legs, so one of the other sides, it doesn't matter which one, is also congruent. Because it's a 90-degree angle, all right? Think about it in terms of Pythagorean theorem, okay? A squared plus b squared equals c squared. If you know that c squared is equal to c squared, and b squared is equal to b squared, obviously a squared is going to be the same thing. All right, that's why this works, because it's a right triangle. That's the only case that it works. If it's not a right triangle, you cannot say that they're congruent by SSA. Now, just because it is a right triangle does not mean it's automatically congruent by hypotenuse leg. You still got to be careful with how they mark things, because we've already seen some triangles before us that were congruent by side angle side or angle side angle. All right, and they were also right. So just be careful with that. Any questions so far? All right, so last thing we're going to do, we're just going to go through and do some more congruency, and we're going to do some and figure out what it is by what postulate. So, number one, look at it, take a think. Okay, you know what? We're gonna get a little movement going. Okay? Let's do some four corners because there's only 5 postulates. So the corner by the door is side, side, side. The corner by my desk, and don't go behind my desk, or just stand by my desk, is side, angle, side. The corner by the testing folders is angle, side, angle. The corner by the filing cabinet is angle, angle, side. And then the middle of the room is hypotenuse leg. All right? So, again, side, 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 angle, side, angle, side, angle, 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 side. All right? And here, I'll do this. So, side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And then you just got to remember hypotenuse leg is in the middle. All right. You guys ready? Go to the corner that you think number 1 is.
I was gonna ask you about like
Oh,
to
yeah.
teach me, or if there's a lesson on like the assess like all the letter things.
I think there's one.
Okay, yeah, because I need to do it because I didn't get a chance to do it yesterday.
All right. If you are standing in this corner, you are correct to the side, side, side. Okay, great. Since you're on a crunch, just
Can I sit down?
yeah. All right. Now look at number 2. All right. So if you don't have your paper in front of you, just look at the board real quick. Don't sit down. Go to the side that you think it is true. All right. If you're standing over by my desk, you are correct.
I can try. I guess.
At least you're trying.
Yeah, I'm like about.
So, why is this side angle side not hypotenuse leg? Because first off, the hypotenuse is not one of the congruent sides. And even though the 90-degree angle is the angle that's between the 2 sides, we know that right angles are always congruent because they're always going to be 90 degrees in their height slicing. All right? So that's side angle side. By the way, if we don't have enough information, have a seat. Okay? I forgot to say that. All right, let's do number 3. So again, the corners, hypotenuse legs in the middle. If there's not enough info, have a seat. So number 3. Yeah, go ahead. Okay, when we do classwork, we'll talk about it. So guys, yes, this one is definitely not enough info. All right. So this one would be SSA, and it's not a right triangle, so we can't use hypotenuse leg. All right. Let's try this next one. So looking at the next one down, so the next section. Let's do number 5 on the next section. What do you think number 5 is? So 5 on the next section, so section 2. What's 5? So 5 on the next section. So just look on the board currently. That's what I'm looking at. If it helps. Yeah. If it helps, just look at the board. Good. It is angle, side, angle. All right. What about, let's go 2. What's number 2?
This one?
Oh wait,
Close. So if you're standing in the middle, you're correct. It's hypotenuse leg. So remember, this is the only form of ass that actually works. So because of that right angle right there, they share a leg, and the hypotenuses are also marked through it. Hypotenuse leg. All right. All right. Last one. Let's do. Let's do 6. So number 6, what do you think it is? So number 6, what do you think it is?
All right, Richard, the teacher. I'm joking. I'm joking. I have it written down on my
All right,
phone.
so go
I
ahead
can
and
give it
see.
to you, but I don't remember what it is.
Okay, so all right. So any questions on the congruent triangle postulates? Now, I know some of you are still a little bit confused. If you are, ask your group mates first. If they can explain it to you and you understand it, that's fine. If you're still confused, come see me. Okay, I will gladly try and help you again. All right, so your assignment, you got another Delta Math that's just as short as the one from yesterday. So use this last 20 minutes and work through that. The one that I'm assigned today is due to not tomorrow night, but Monday night by midnight. But the one from yesterday is due tonight by midnight.